And there we go. So we watched that video the other day, and there's this online app for playing around with springs. It's way more fun to do the real experiment than the virtual one. So for our real experiment here, we are going to take some weights, and they're labeled 1,000 grams, which is a kilogram, 500 grams, and so on. And we're going to measure displacement. Displacement is how far it moves. So for example, in that video that was played here, he didn't have the spring starting at 0 centimeters. It started at, I don't know what number, we'd have to go look back and see, and then he noted where it ended up. So you'd have to do a subtraction to figure out how far the spring traveled. Okay, so how far it traveled is called its displacement, and springs can be compressed or springs can be stretched. If they're compressed too much, they can be damaged and not work right. If they're stretched too much, they can be damaged. These weights won't damage the springs I have here. So we are going to try this experiment right now. So here I have set up a little stand to help me because I'm working alone. Daisy's going to help virtually, so zoom in on this screen the best you can. So I have a 500 gram mass here. I tried to get my spring started at 0 on the clear ruler, and I'm going to hang it on there, and I want to see where the, oh dear. I want to see where the base of that spring ends up. All right, let's see, is it back in the right spot? Close enough. All right, try that again. Hang my weight. And then Daisy, could you also be my recorder, write down what we get here?
Yeah.
Okay. So it looks like, let me get a pencil to help find that new number. Oh, it's off the screen too. Tilt the camera.
Yeah, and I can't see it.
All right. Oops, I gotta fix my presenter here. All right. Oop. Should be good. Okay, what do we got there? We have 19. It's pretty close to 19 and a half. So we're looking at the bottom of the spring right there. What do you think? 19.4, Daisy? 19.5? That's 20 right there.
19.4.
Okay, so write down 500 grams, 19.4 centimeters. Robert?
I'm just wondering, you're going from the bottom of the spring part, not the clamp?
I'm going from the bottom of the spring, not the hanger. Yeah.
Are we writing this down too?
No, you guys are going to do your own in a minute. So I got the bottom of the spring set pretty close to 0 on my thing there. So that was 500. I don't have a 400 gram one, but I'm going to take two 200s and stick them together. And we'll see where that one goes. So you guys are going to do the same exact thing. You're going to take a bunch of different weights. I'd recommend having at least 5 points in the end. A point means what's the weight, what's the displacement. All right, so here, oops, I moved it. The displacement looks to be, let's see on the screen. What number is that? 15 point something. 15.3 maybe? What do you think, Daisy? 15.2, 3, 4?
0.3.
0.3, okay, make a note of that. 400 grams, 15.3. All right, and if you guys are bored watching me, you can grab some stuff here, choose a spring, and set yourselves up to do this. Go for it. So you need to find a way to measure. Okay, I'm doing 300 next. Let's see what we got, Daisy. Looks to me like 11 point something. 11.2.
Is it past 11?
Yeah, I'm looking at it sideways, and here's 11 right there. And it seems a little lower than that. Maybe you're right. Maybe it's pretty close to 11. We could go with 11 on that. Yep, go with 11. So 300 grams. So you guys got to find a way to make that happen. I get the fancy stand. Yeah. If you want, You can use anything you want. All right, so I'm going to do 200 next. All right. So looking at it sideways, it's just above 7. 7.7 maybe? It's after 7.5.
So it's like that.
Yeah, I think we should go with 7.7 on that one.
Really? Because it looks like below 7 from what I'm looking at.
Well, I'm looking at so this part of the spring right here. Here's 7 right there. So I think we're a little above 7 because I want the bottom of the spring, not the hanger.
Yeah.
Oh yeah, below, I'm sorry, you're right.
So
6.7. That's what I meant. You are correct. It is below 7. Yeah. How about 6.7?
perfect.
Okay. Thank you for correcting me. So that's 200. Let's do 100, and then I think that gives us 5 points, right? Okay. So 100 looks to be 2.5, maybe?
A lot heavier than I expected it.
Yeah, I'm thinking 2.5. What do you think?
Yeah.
Okay, so we got 2.5 centimeters.
Where goes the
All right.
end of it goes at 0, right?
You decide.
Top.
You get to pick this. You just got to figure out how far did the spring stretch when you put a weight on it.
So it should be stuck.
So how do you set it up to make that happen? All right, next thing we're going to do, Daisy, is we're going to take my mystery cup, my exploding kittens cup, and we're going to weigh it and then use a model to figure out. Ooh, oh man, I broke it. All right. Hang on. Should have got a better clamp. All right, so put that there. And we got to line this thing up.
Know where the end of this is. This is difficult without that little gadget you got.
I know it is, huh? I went to the science department and borrowed this.
So like,
Okay, I think that's pretty close to 0 there. So I can clamp it again.
it'd be like.
Okay. How am I doing there? Yeah, okay. Let's see if I can get my exploding kittens cup on there again.
Whoa. Getting hot. That was like a finger workout.
Okay. Now this is pushing it out a little, so it's going to be a little harder to see. I'm guessing 13. Pretty darn close to 13, don't you think?
Yeah.
Okay, so just go with 13 then.
Oh, no.
Okay, so that's all we know is it's 13 centimeters, but we don't know its mass. We're gonna have to go back and figure that out. All right, so let's put this in a spreadsheet. So I'm gonna ask you to read the numbers back to me. Let's switch to my sheet.
Can't see it. Okay.
Okay,
Yeah.
all right. So I'm done with the stand if anyone wants to use it.
Grab that.
Last time I did this, I hung things off the desk. Like I put held a pencil on the desk, hooked the spring on the pencil. So you could try that. All right, so let's see. We need to keep track of the mass and the distance. And I guess I should make a note that the masses are in grams and the distances are in centimeters. Okay, so let's see. We did 500, 400, 300, 200, 100, and then we have the mystery mass. What were our distances, Daisy?
For the 500 gram, it was 19.4 centimeters.
Okay. And 400?
15.3.
15.3. Okay.
11.
Okay.
6.7.
Put that out there.
0.7, all right.
2.5.
2.5, and then the mystery,
13.
13. Okay. So we need to find a model for this. So do you have a computer with you, Daisy?
Yeah.
Okay, so take a minute to type those same numbers into a spreadsheet on your computer.
Okay.
Okay, we did it. It took a minute.
Because what I want to do is have the computer make a chart for me, so I can see if these points really line up.
A scatter plot.
Scatter plot, correct.
Wait.
Wow, look at that. That makes a nice line there.
We don't have a ruler that
It
long.
doesn't start at 10. I forgot. It is 11 for the spring.
Our ruler's not that long.
So it looks like you probably can't use a kilogram
Okay.
with that system.
On the last one.
Although I do,
Really?
this is kind of crude, but
We started.
there is this guy right here.
Oh. Alright. No.
Or you could just hold another ruler under that one and add things up.
Okay. That would work.
Hang it off the table maybe.
But we have mine's-
Yeah, I wanted to do a kilogram too, but I didn't have enough room.
Because we started on.
I have to hang it off, right? Wait, so this is. Oh.
Yeah, so you'd have to subtract off the 10 wherever you started from.
Yeah.
You need to figure out how far the spring got
We started
stretched.
up here.
I'm scared.
Okay, so let's see, Daisy. We need to find a slope,
Had it on there.
Is it there because it's?
and slope is rise over run. Slope,
18.
rise,
So 12.
and run.
But,
When
because
did
it's
you
the
get,
spring.
it was the end of this part, right?
Okay, so let's see.
This is
So
11.
it
This
was
is the
built
starting
like
point of 11.
Daisy, we have to pick which two
So it's
points we want to
12,
find the
like,
line through.
But before we were going down here, so we had to, forgot to take off this 10. Because it was easier to hold it.
So, I'm gonna put a straight edge up to that,
It is what?
and those points line up nice. I think we could just pick the first and the last.
How much one was that? It was 1,000. Okay.
1,000 grams,
1,000 grams.
which is a kilogram, yeah, 1,000 grams. Which spring are you using? Yeah, so we have two different, so even though two of these springs look alike, they're not exactly the same, so they won't stretch exactly the same amount. They should be kind of similar. What'd you get? What did you weigh just now? How much mass was on there?
10 equals 0.
How much mass was on this? How much are the
Oh,
weights?
250.
So you did 250 and it stretched how far?
No.
Minus where you started from.
That had 17.
So it stretched 17 centimeters for 250?
It stretched to 28, and you take away the 11, which made it 17.
Yeah, that could be. Yeah, that's a slightly different spring than the one I used, I think.
And
All
you
right.
take away the 11, right?
You with me, Daisy?
10.
So for the rise, so I think I'm going to use the first and the last point. So ultimately, I want, given a displacement, I want to figure out what the mass is. So I think I have these two columns backwards. So
That's what you subtracted.
I think I'm going to switch that. So let me copy this into a new sheet. There we go, copy. All right, let's delete this and do that again. So I'm going to move these.
We can either do 120 or just do 100.
Okay. So given the centimeters, we'll figure out what the mass is. Let's do it that way. So I'm going to regraph it. It'll still line up.
It don't seem like we should.
It'll just be the reverse slope or inverse slope.
Wait, so then we'll just do 200. Yeah, all right.
Okay, so there they are lining up. Okay, let's move that. So then my rise, so I'm going to use these, the first and the last point. And so my rise would be the change in mass. So I'm just going to go equals this number minus this number. That's going to be my rise here. My run would then be the displacement, change in displacement. So this one minus this one.
I'm right here. It's like.
And then the slope, I'll divide those two. So I have to take my 400, divide by my 16.9. And then let's take it to one more decimal place than we measured. So we'll take that down to 2 decimal places. So we're getting a slope of like 23.67. What does that tell us? That, let's see, rise is measured in grams, and run is measured in centimeters. So we're calling it 24/1. So for every additional centimeter we stretched, then the thing must be about 24 grams heavier, is what that slope tells us. All right, next thing we need to do is figure out what's our y-intercept here. So that would mean if the spring didn't get stretched. So if the spring didn't get stretched, what do you predict its weight's going to be?
Constant if it wasn't stretched.
It wasn't stretched, yeah, there'd be no weight, right? It'd be 0. So that's one possibility. So one model could be to predict the mass. The mass would be equal to our new number, our slope, 23.67, times whatever the distance was. And it would be plus 0 because if there's no distance, there's no mass. Now, a lot of springs aren't sensitive enough to notice a really light weight. Like if we hung a feather on there, it wouldn't measure. So we're just going to double check that by taking those 2 points into a notebook and finding a y-intercept based on those 2 points. So just to double check, let's get a screenshot of our data. Did you all measure the cup too? Yeah, you got to measure the cup because we're going to then use your model to predict the mass of the cup.
Oh, okay.
Yeah. So you'll have to measure the cup too. With your springs is important. Okay, so let's see. What do we got here? The 2 points that we are using are this one here and this one here. And so far, if this is our y and that's our x, we think that y is equal to 23.67 times x. And let's say we're questioning the y-intercept of 0, so we're just going to put a b there because we don't know yet. Then what we do is plug in one of these points. So for example, I'll plug in the 2.5, 100. So if y is 100 here, put the 23.67 back, then the x value would have to be 2.5. And now we can solve for b. We need to whip out a calculator.
59.175, 100.
0.5. Do that right.
59.175. I
5.
got 40.8.
Okay, so we have to subtract that. So yeah, it'd be about 40.8. That'll work. All right, so we think our new formula is y equals 23.67 times the displacement plus 40.8. And actually, let's take that to 2 decimal places. So if we made that 1/8, this would be 7/2. Not that it's going to matter too much. All right, or would it be 8/2? It'll be 8.
Minus 59.
Okay. So back in our model, we have one model there, so we have an alternate. there would equal 23.67 times the x value plus 40.82. All right. So let's use one of those, like let's use our alternative to figure out the mass here. So we would just go equals 23.67 times the distance we saw the cup stretch, the spring, plus 40.82. Our prediction would be about 348, 349 grams, according to our model. Just for fun, we're going to find one more model. I'm going to do what's called linear regression. And that's where we can have the spreadsheet find the model for us. So I am going to move this to its own sheet. Error. Like that. Try one more time. There we go. To get that, we have to edit the chart and then customize series. So we did this in class yesterday. And we want to add a trend line to it. And we want to label by showing the equation. Oops, I did that on the wrong one. Cancel that. Delete chart. The wrong sheet. On this sheet here. I want the displacement along the bottom. Yeah, and the mass on the side. There we go. That's better. All right. Edit chart. Customize. Series. Okay, so that's what we get. So this says 23.6, which is pretty much what we got, and a y-intercept of 41.1. We thought it was like 40.8. So the model is pretty darn close. Bounce on this. So those numbers tell us 23.6 and 41.1. Linear regression model there is mass equals 23.6 times the displacement plus 41.1. I'm just going to come over here. So this is our alternate linear regression. 6, 13 centimeters meter. That one says pretty close to the same number, about 348 grams. Our models are consistent, there's just different ways to come up with models. All right, so we are almost done with that part. So two things are going to happen for this. So can I have everyone's attention just for a minute? I know you're all in the middle of hard work there. Take a look at our lesson. So first stage of this was to make some measurements and write them down. Then after that, you're going to try and make a graph by hand. I don't know if you already started that. And then pick 2 points on that and come up with an equation. So Daisy and I just went over that. And then you want to tell me what the slope means and then see if you can use your equation to figure out how much the mystery cup weighs. So my model and Daisy's model came up with like 348 grams. Yours may be slightly different than that. If it's way off, then we got to revisit your data or how you came up with your line. Later, either once you finish it on paper or after class, you're going to go try and do the same thing on a spreadsheet. Type your data in on the spreadsheets, have the spreadsheet create a chart for you, and then we can ask the spreadsheet to find the trend line through the data and see how it compares to the one we found. It's going to be pretty darn close, okay? But the computer can do it too. All right, go for it. Daisy, start working on that paper and let me know if you have any questions.
Will do.
Thank you.
Plot all of your points. How many points did you make? Yeah, plot all 5 points. They should line up. So then you want to estimate a line through those points and pick which 2 points you're going to use to calculate your line. Remember how we did that the other day in class? Yep. Okay, go for it.
Yeah.
Huh? No, I just did it on the second.
What is this?
This other one back there. I got this simple. 1,000-pound weight is way on here.
Oh yeah, that one doesn't line up. So I would
The weight.
maybe ditch the 1,000 gram one and maybe do a different one to get a 5th point. 4 points might be enough. Yeah, I put the 1,000 on there and I decided I couldn't easily measure it by myself. Did anyone try using one of the little springs?
We attempted, but it was very hard, so we switched.
Yeah, the problem with the little spring is they're tougher steel and they don't stretch as much. And it's also the smaller diameter. Right? So the little spring is harder to work with.
We feel like an estimate of the box.
What's that?
Exact.
Yeah, so then just pick 2 points on that line and try and, so you decide which 2 points you're going to use to find the equation for your line. And confirm with Emily that you want to do it that way. But
That's what our,
I didn't get that mine.
is
30.
our starting point. Right here, yeah.
Put these up here. And these up there.
What's up?
Well, yeah, I have no idea what's going on.
Okay. So those are all your points. Did you draw a line through them? Okay. So that would mean you had some errors in your procedure. So you can either remeasure some stuff, or you can just throw your ruler down and make a line. And decide
Do it.
which line you like.
Even with this though, because like.
Well, so which 2 points did you just pick?
I picked
500 and 400, so that's what, this one right here,
Mhm.
and that one right there.
Mhm.
Okay. So then the line you're about to find is that one right there. Does that fit the pattern? Yep. Okay.
And so.
And then we can either side, maybe that one's an error, and it was more like this, or like that. And the other side, you could draw that line, get 2 points on that line instead of 2 data points, and come up with an equation. So that's the next part of your experiment here. How do you use the data? So I would chuck that point. They have the same, this is the 1,000 kilogram one.
Yeah.
Oh, here's another problem. Your scale's off. Because from here to here, you're saying that's 500. Now you're saying from here to there is 500. That's like me saying, okay, this is 1 foot from here to here. Now here's a foot from here to here, and let's let this be a foot. So really that point right there would have to be the same distance. See, 500 is about right there. So 1,000 would be here somewhere.
They always would give me that.
So
They're always trying.
Did,
Then I go home, my dad would
there
just.
is here somewhere. Which,
Technically, it's still in
That's
the
bad.
area.
yeah, so that's the wrong spot. Yeah, so it is okay, you just, you must understand
I
that.
need more
Okay.
three cans.
Yeah, it looks pretty good like that.
I'm still hanging on.
And
You can
then-
still use that.
And theoretically, you would think that
Well,
the
they did
point
once,
zero
and
zero,
yeah.
but this, the spring isn't sensitive enough to notice like the weight of the pen here. So it could be, we don't even see the spring move till we put like 30, 40 grams on there. Yeah, so it could be our line set is way up here. And that's what your data looks like, that's what my data looks like. That's what your data-
Okay.
Yeah, so I would say maybe this point and that point.
Okay.
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 That is an excellent question. All right, how's it going over here? Any progress?
I don't think a lot of that right. So then I just, I wait, I put a period.
Yeah, that's what I did too. Yeah, I put the centimeters across the bottom and the weights on the side.
So this is what I end up with.
So,
Yeah.
so 50 divided by 3? Okay, so what's that give you? Calculator.
And the 50?
Headache.
So you get a slope of about 16?
Yeah.
16.7, I guess I would call it. I got a slope of about 23. So let's check another point. So let's suppose we use this one up here. So what's this point now? Okay, so we look at 4.
Everybody use this point.
Yeah, but that point's off, right? Something's wrong. So let's say we use these 2 points right here.
Yeah.
So here we have a rise of 400
Yeah, I agree.
and a run of, where did this start at? 100 was what?
It started at 1.
Started at 1. And we want to get to, what was the displacement for 500? Okay, so if I use this point up here, I'm getting a rise of
And then you
400.
put those two on the top.
What's that? It's probably-
Yes, yes.
Okay.
Oh, I went up by 100 or 50. And then 10.
And that gives me about 15, so it's in the same ballpark. Yeah, so you have to decide which one you want your slope to be. And then you got to figure out your y-intercept. So which 2 points did you guys decide to do? Which 2 points did you decide to work with? Have you decided yet?
Yeah, we'll probably the 1.
So it was 1 centimeter went with 100 grams. And how many centimeters? 28 centimeters went with 500.
Yeah.
Okay. So then we have a slope of 400 over 27. And that came out to what? 14.8. So now as far as like a y equals mx plus b, you've got m is 14.8.
In the table, that one would go first.
So then I plug in one of these points here. So like maybe I'll plug in the first one. X is 1 and y is 100.
We'll just see.
So now you can calculate what b is.
Starting point was 1.
No, we need to know the starting point for grams, because that's the output. That's what B tells us, not the starting point for centimeters. So what's that going to give us? 85.2. So it looks like your model, Y is your mass, equals 14.8 times the displacement plus 85.2. That's what you think your model is based on those 2 points. So the next 2 questions are to interpret the slope. What does 14.8 mean here? And then plug in the mystery distance to figure out what the weight of the cup is. Okay, cool. So next thing you're going to do is you're going to draw a line. What is your line here? You got to decide, and then find the equation of that line. So that's what I was talking about.
Wait, if the line does not go to all the points.
It can't, because those points don't line up perfectly. So you decide what's the best line.
Y2. It goes to
19.
It's your call. You have to decide.
Okay, there's no wrong answer.
There is technically no wrong answer.
Okay.
Yes, so don't worry so much, just do it. How you doing out there, Daisy?
That came from failing.
Good.
So stupid.